Welcome to Zigmatech Consult Limited. Today we'll learn mathematics, and in our mathematics today we'll be looking at square and square roots. Square and square root. Looking at how to square a number and how to square root a number. Okay. So by way of introduction, our learning objective will be by the end of the lesson, learners, which is you, should be able to define the square of a number, define the square root of a number, and calculate the square and the square roots of numbers. So these are the things that we aim to achieve by the end of this class. Okay, so let's look at what we have there. Definition of square and square roots of numbers. Okay, from the slide we have there, we say the square of a number is the product of a number that has been multiplied by itself. Is the product of a number that has been multiplied by itself. So if we take, for instance, we say that the square of a number, let's assume of a figure, let's say A, square of A is equal to A multiplied by itself, A, to give us A square. So this is what the square of a number is. Is that okay? So we say that the square of a number is the product of a number that has been multiplied by itself. So the product. So if we say A multiplied by A square is the square of that number A. Let's assume, for example, 4 is a square number of 2. Is a square of 2. Do you understand? What that means is that if we multiply 2 by 2, which is itself, it will give us what we call a square. Is that okay now? So that 4 is the square of 2. It is the product when we multiply a number by itself. Do you understand the point? That is what is the square of that number. Okay, so then on the other hand, the square root of a number is a value which on multiplication by itself gives the original number. Do you understand? On multiplication by itself, it gives the original number. The square root is an inverse method. It's just like the opposite of, or the inverse method of squaring a number. Okay? So if we had said that 2 multiplied 2 is equal to 4, so we are saying that the square root of a number is a value which on multiplication by itself gives the original number. So this multiplication that is by itself, one of them is the square root, which is like 2. So it is the square root of this 4. So this is the square root of this. Why? This is the square of this. It's just like an inverse of what we have in the square and what we have in the square root, as the case may be for each of them. All right, so we said perfect square. Perfect square roots have a whole number as the principal square root. Okay, perfect squares are those numbers that have a square root. Okay, those numbers that have a square root that when we obtain their square root, there is no decimal. Okay. All right, those are perfect squares. They are those numbers that when we multiply by the product we get as a result of multiplying a number that is real number by itself. Do you understand the point? Okay, so why imperfect square roots have fractions or decimal as their roots? Is that okay? All right, so for instance, if we say square root of 12, there is no two numbers that when you multiply them can give you 12. No two numbers. That is why if we want to find the square root of 12, it will give us a decimal number, because no real number, no single number multiply itself to give us 12. Same with something like 17, same with 18, same with 19. We call those numbers imperfect squares. But a number, for example, like 4, we call it a perfect square. Why is it a perfect square? It's a perfect square because we have a number that will multiply itself and give us 4. So 2 times 2 is 4. So because of that, we say 4 is a perfect square. Do you understand? 9 is a perfect square. All right? 16 is a perfect square. 25 is a perfect square. All right? 36 is a perfect square, just like that. Okay? 49, perfect square. 64, perfect square. Okay? So all those things are what we refer to as what? Perfect squares. All right. So having gotten an understanding or a foundation of what square and what square roots are, it is in your exams, you will see questions that your examiners will be testing you on your knowledge of especially square roots, okay? On your knowledge of square roots, and in some cases, your knowledge of squares, okay? All right, so we're going to look at some ways or principles of calculating perfect squares, calculating the roots of numbers. For instance, I know you know, if you are asked what is the square root of 4, you know it's 2. Square root of 16, you know it's 4. Square root of 9, you know it's 3, 25. They can get to very large numbers, and they ask you for their square root, and you may not be very conversant with those numbers. But there is a principle and a rule that you can apply in solving for the perfect squares of the square root of numbers. Okay? So let's look at our ExamGuide learning app, pick some questions there, and solve them. All right? Okay. So let's look at the first question that we have here. The first question says, what is the square of 30? What is the square of 30? So let's look at that. Number one, they're asking us of the square of 30. So the solution is simple. Remember, from our definition of a square, it is to multiply a number by itself. So the product, it is the product of a number that is multiplied by itself. That product is the square of that given number. All right, so for 30, this means square of 30, which is mathematically denoted as 30 raised to power 2. So 30 raised to power 2 is equal to 30 times 30. That's what it means. So anytime you see square root of whatsoever, it means that number raised to power what? 2. It means it is multiplying itself. So 30 times 30. So this is 30 times 30. 0 times 0 is 0. 0 times 3 is 0. 3 times 0 is 0. 3 times 3 is 9. So this will give us, if we add this, 0, 0, 9. So to give us 900. So 30 square is equal to 900. So that is what the value of 30 square is. So it means that the square of 30 is the product. Product is the answer you get when you multiply numbers or figures or symbols, whatever it is. That is the product. So that is the answer to that. So that is for, what is it called? For square of a number. Okay? And let's look at some other question. Now let's look at this before we come back to. Let's look at this. This question says, evaluate 25 minus square root of 5. Number 2. Evaluate 25 minus square root of 25. Okay? Now, this is equal to, I will intentionally, this is 25 minus square root of 25. So this is 25 minus, I know you know the square root of 25. I will intentionally, because this being a small number, which you know, okay, let's just have the answer which you also know. So square root of 25, you know, is 5. Okay? Remember, the square root of a number is the number we get when that number, or that is the value we get as a result of two numbers that were added, that were multiplied together. One of them that was added is the square root of a number that is given. Okay? So this is 5. All right? It means that this is equal to 20. So square root of 25 is 5. So 25 minus that 5 gives us 20 as the answer. Now let's look at this. Let's look at, they say we should find the square root of 144 divided by 256. The square root of 144, so we're looking for the square root of 144 over 256. Solution. Expressing this statement mathematically, this means they're asking us to find the square root of 144 divided by 256. That's what they're asking us to do. I know, but some of you, you may know that square root of, what square root of 144 is. I know you may know. Some of you, you may also know what this 256 is. But at this point now, you see that the numbers are beginning to be complex, are beginning to be very large. And some of us may not know what this. So there is a principle in simplifying larger numbers like this to get your, what is it called? The root, the square root of those particular numbers given. So this is what we are going to do. We'll look for the square root of 144, and we'll look for the square root of, what is it called? 256. Then once we do that, we can now simplify the fraction. So this is equal to square root of 144 divided by square root of 256. All right? So let's look for square root of 244, of 144 rather. So this is how to find square root of large numbers. All right? Now, let me even start from this 25. How did we get 5? Some of you may begin to ask, how do you, I know you know 5 times 5 is 25, meaning square root of 25 is the 5 used to get 25. But let's assume there is another way, which is what we are going to be applying now. This 25, okay, if we find a factor that can divide 25, that factor is 5. So 5 here is 5. So factor that can divide 5 is also 5 and 1. So square root, okay, since it is two numbers that are used to get this, you know 5 times 5 is 25. So we bring out one of them out as 5. So that is why we say the square root of this is 5. Do you understand? So let's also look at 144 and see what we apply in getting this in 144. So if we have, so square root of square root of 144 is equal to 144 all over what? Let's say the factor here is 2. 2 here. 2 into 14 is 7. 2 into 4 is 2. 2 can still go. 2 into 7 is 3, remainder 1. We put it here, it becomes 12. 2 into 12 is 6, right? 2 can still go. 2 into 36 is 18. That is 2 into 3 is 1, remainder 1. Put it here, it becomes 16. 2 into 16 is 8. Another thing that can go is 2. 2 into 18 is 9. Another thing that can go is what? 3. 2 can't go again. 3 into 9 is 3. Another thing that will go again is 3. 3 into itself is 1. So we group those factors we use to reduce 144 or the number to 1. We group them in twos. All right. So this is this, and this. So we bring out each of them that we grouped in twos. So here we are bringing out 2. We are bringing out 2 here. We are bringing out 2 here. It means that the square root will now be equals to 2 times 2 times 3. Sorry, this is 3, not 2. We bring out 2 here. 2, we bring it out here. Why 3? We bring it as here. So 2 times 2 is equal to 4. 4 times 3 is equal to 12. That is why the square root of 144 is equal to 12. So it means that here we're having 12. Square root of 144 is equal to 12. Can you see what we have there? Then we go to 256. All right? Let's have 256 here. Let's just draw here so that we'll use this place to get our answer here. All right. So square root of 256 will be equal to, if we have 256 divided, okay, what is a factor of 256? We'll begin with the least factor. 2 is a factor there. So 2 here, 2 into 2 is 1. 2 into 5 is 2. Remainder 1, put it here, becomes 16. 2 into 16 is 8. So it's 128. 2 again is a factor. 2 into 12 is 6. 2 into 8 is 4. 2 is also a factor. 2 into 6 is 3. 2 into 4 is 2. 2 is also a factor. 2 into 3 is 1, remainder 1. We put it in this 2, it becomes 12. 2 into 12 is 6. What else is a factor? 2 again is a factor. 2 into 16 is 8, right? Then, what else again? 2 is a factor too. 2 into 8 is 4. What else? 2 is a factor. 2 into 4 is 2. What else? 2 is also a factor. 2 into itself is 1. So we group in twos like we did in 144. So here, these are 2. These are this in twos and in twos. For each of the grouping, we bring out one of the numbers. So this is 2. This is 2 here. This is 2 here. This is 2 here. So we say, therefore, the square root of 256 is this 2 multiplied by this 2, multiplied by this 2, and multiplied by the last 2, which will give us 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So the square root of 256 is 16. Do you see this now? Which is equal to, remember, this can still be simplified. 12 over 16 can still be very much simplified. How do you mean? They have common factors. 2 is a common factor of these two. Okay, I will always tell you, begin with a very simple factor that you know. Okay, all right. We know that 4 is also a factor of this, but don't just begin with the simplest one so that you don't give yourself problems. Okay, 2 in 12 will give us 6. 2 in 16 will give us what? 8. Is that okay? 2 is also a factor. 2 in 6 will give us 3. 2 in 8 will give us 4. Is that okay? So we're having 3 all over 4. 3 all over what? 4. Which is option C as the correct option. 3 all over 4 as the correct option. Okay, so that is how to find square root of numbers, of larger numbers. We'll look at larger numbers and see how we can also find the square root of these things, okay? Alternatively, another form that we can use in doing this, apart from this, because in exam, you may not have the luxury of time to do all this. Another way is that you can simplify this to a point that you can find their square root. Do you understand the point now? For instance, I am saying alternatively, we're having what? 144 divided by 256. So let's just simplify this. The common factor here is 2. 2 into 144 is 128. How? 2 into 14 is 7. 2 into 2 is 2, 72, right? 2 into 2 is 1. 2 into 5 is what? 2. Remember, 1 will put it here. 2 into 16 is 8. So 128. So we're having 72 over 128. 2 can still go, right? So 2 into 72, 2 into 7 will give us 3, remainder 1. 3 remainder 1, we'll put it here, it's 12. So 2 into 12 is 6. So this is 36. Why here? 2 into 12 is 6. 2 into 8 is 4. So we're having 36 all over 64. Now, at this point, it is easier. Remember, we are still having the square root. At this point, it is easier for you to, you know that the square root of 36 is 6, while square root of 8 is what? Is square root of 64 is 8. You can go ahead and still simplify further, right? 36 divided by 2, here we'll have what? Let's see, 36 into 2. 2 into 3 is 1. Put 1 here, 16. 2 into 16 is 8. All right? Here, 2 into 6 is 3. Why 2 into this one is 2? So it's 1832, right? We can still go. 2 into 18 is 9. 2 into 32 is 2 into 3 is 1. Remember 1 put here. 2 into 12 is 6. Right? So now if we look at this, you can see that 9 and 16, they can still 9 and 16, they don't have common factors. Do you understand that now? So at this point, what is the square root of 9? 3. What is the square root of 16? 4, which is the 3 over 4 that we also got at this point. Is that okay? All right, so whichever way works for you, you can apply it in your solving. Okay, look at this one. This says we should evaluate square root of 2 whole number 1 over 4. We should evaluate it. So it's the square root of this. So it is simple. So let's convert this to improper fraction. Okay? So this is 2 times 4, 8, plus 1, 9. So this is 9 all over 4. So this means that the square root of 9 is 3, while the square root of 4 is 2. So this will give us 2 divide this will give us 1 whole number 1 over 2. So 1 whole number 1 over 2, okay, or 3 over 2. They didn't convert it to mixed number. So 3 all over 2 is the answer for this particular one. All right? Okay, so let's solve one other question here. It says find the square root of 196. So we want to look at the square root of 196. So mathematically, this is denoted as 196 square root. All right, 196. So what do we do? Is just to divide 196 until we get to 0, until we get to 1. So this is 196. So 2 is a factor here. 2 into 19. 2 into 19 will give us 9, remainder 1. Put it in 6, it is 16. 2 into 16 is 8. All right? So 2 is also a factor. 2 into 98, 2 into 9 is 4. Remainder 1, put it here, it becomes 18. 2 into 18 is 9. 2 is not a factor of 49. Okay? 7 is. 7 into 49 is 7. Then 7 again into 7 is 1. So we group in twos. We group in twos. So this is 2 and this is 2. So this means that the root of 196 is equal to 2. Please, this is 7. I'm bringing one of these out. 2 times 7, which is equal to 14. So 14 times 14, what that means is 14 times 7 gives us 196. Okay, so this is the answer to this particular one. All right, so let's look at 75 over 300. They say we should find the square root of 75 over 300. 75 over 300. So this is, solution of this is, okay, so this is mathematically expressed as root of 75 all over 300. All right? Root of 75 over 300. Now, what this means is that if you look very well here, this 75 has a perfect square that can be multiplied to get 75. You know that 75 could be 25 times 3. 25 times 3 is also 75. All right? Then, for 300, why I'm doing this is because 75 is not a perfect square. 300 is not a perfect square, so they can't have a perfect square root. They will have a square root that is a decimal. Remember in our introductory part of this class, we said that perfect squares will give a square root that is a whole number. But imperfect squares will give a square root that is either a fraction or a decimal number. Do you understand me, as the case may be? So 75 is an imperfect square. 300 is an imperfect square. So I want to bring out a perfect square of 75. For me to do that, what I can do is multiply a perfect square by something to give us 25. To give us 25. So 25 multiplied by 3 give us what we have here. Okay? So for 300, what can we multiply? Which perfect square can we multiply with any number to give us 300? 100 is a perfect square. 100 is a perfect square. So we say 100 multiplied by 3 also, right, to give us 300, because 100 times 3 is 300, right? So with this, 3 can cancel 3. You see the points now? To give us square root of 25 all over 100. Square root of 25, we had established here to be 5, right? So this will mean 5 divided by Square root of 100, let's get that. 100, let's get the square root. 2 is a factor there. 2 into 100 is 50. 2 into 50 is 25. 2 into 25 cannot go, so 5. 5 into 25 is 5. 5 into 5 is 1. So in twos, we have 2, and this 5 here times 5 to be equal to 10. So the square root of 100 is 10. Is that what it is? So at this point, if we look at our options, there is no 5 over 10. So we simplify to the simplest term, okay? 5 into itself is 1. 5 into 10 is 2. So this is 1 over 2. That is the answer. Now, we can alternatively solve this thing. Alternatively, we can have this square root of 75 all over 300, the reducing term. You know, there is what we did here where we had to reduce, okay? We had to reduce to the least term, then look for the square root. All right, we can do that here. Look at this now. So whichever one that is easy for you, apply it, all right? So if you don't want to use this method, you can use the method I want to also talk about now. So this is 5 into 75 will give us 15. How? So this is root of 5 into 7 is 1. Remainder 2. Put it in 5 to be 25. 5 into 25 is 5. So it's 15 here, divided by 5 into 300 is 60. How? 5 into 30 is 6. 5 into 0 is 0. So this is 60. So 5 is still a common factor between the two numbers now. Okay? So 5 into 15 is 3. And 5 into 60 is 12. Now look at this. Look at that. We have, let me bring it this way. We have root of 3 over 12. Root of 3 over 12. 3 is an imperfect square. 12 is also an imperfect square. You see, what we did here for 75 and 30, we are also going to do it here. So let's look for a number that when we multiply, there should be a perfect square from there. Remember, I forgot to tell you, you know, 1 is also a perfect square because 1 times 1 is 1. So 1 is a perfect square because it is not from that 1 as a perfect square is when 1 multiplies itself. So 1 is a perfect square also. All right? So here, we can introduce 1 as a perfect square to multiply 3 to still give us 3. Right? So this is equal to square root of 1 times 3. You know 1 times 3 is still 3. Right? So then for here, this can be 4, which is a perfect square. Is 4 a perfect square? Yes. 2 times 2 is 4. So 4 is a perfect square. So this can be 4 times what? This 3 cancels this 3. And what we have here now is square root of 1 over 4. So square root of 1 is 1. While square root of 4 is 2. So it's still 1 over 2. So either this way or this way, you will still arrive at the same answer. Okay? Now let's look at, there is some other thing I want us to look at here. All right, it says simplify square root of 144x squared. 144x squared divided by 4. Right? Yes, that is what we're asked to do. So this is what we're asked to do. Simplify 144x squared divided by 4. Square root of 144x squared divided by 4. Okay, so the square root only applies to 144x squared, not divided by 4. Okay, not this 4, which is the divisor. Okay, so this is equal to, remember, let's even have this. 144x squared means what mathematically? Let's express it mathematically. It means 144 times x squared. That's what it means. Right? So this can mean square root of 144 times square root of x squared. Are you with me? All right. So this is what this means. But before we do that, please, let's not forget to maintain our divided by 4. So this will now mean root of 144 times x, root of x squared. Is that okay? Divided by 4 again. Is that okay now? All right. Now, we have established that root of 144, from what we have done so far, root of 144 is what? 12. All right? Because 12 times 12 is 144. All right? So, 144 is 12 times, you know, we said when you square root a squared number or a squared letter or whatsoever, the square, okay, removes the square root. So this square takes off the square root to give us x. All right? All over what? 4. So this means 12x times x, 12 times x rather, will give us 12x divided by 4. Right? So 4 divided 12x is equal to 3 what? X. And that is the answer to this particular question. This is the answer to this particular question. Let's see if we can. Okay, so look at this question. You will have to solve it. It's similar to what we've done here. Okay, let's take this one. This is an application question. If the sum of the square of 6 and the square root of 81 is divided by 5, the result is what? Right? If the sum of the square root of 6 and the square root of 81 is divided by 5, what is the result? So let's put that in mathematical terms so that we can solve it easily. So this means 6 square, which is, they say the sum, the square of 6 is 6 square. Say the sum. If this sum, when you add it with the square root of 81, so square root of 81 divided by 5. So they say, what is the answer? That is the question. So the first thing to do is 6 times 6. Square, this thing means 6 times 6, right? Plus square root of 81 all over 5. So let's look at the square root of 81. How do we get that? Assume you don't know what it is. So you do 81 square root. Let's get that. So 2 is not a factor of 81. 3 is. So we'll go with 3. 3 into 8. 3 into 8, we go 2. Remember 2, we put 2 to 1, it becomes 21. 3 into 21 is what? 7. Is that okay? The next thing is 3 into 27 is 9. 3 into 9 is 3. 3 into 3 is 1. So we bring it in twos. So this is 3 and this is 3, right? So that is why square root of 81 is equal to 3 times 3, which is equal to 9. Square root of 81 is 9. So this is equal to, this times this is 36 plus 9 all over 5. So 36, excuse me, plus 9. So this gives us 15. Write down 5, carry 1 here, becomes 4. So this is 45 divided by 5. Okay? And of course, 49 divided by 5 is 9. So what the result will be is 9. All right? Okay, so I think this is the point we will have to end this for now. You have some questions on your ExamGuide learning app that you can practice how to solve questions on square and square roots. They say practice make perfect. As you keep practicing, you will be perfect in this particular topic. Thank you very much. I'll see you again.